Welcome to Samples and Populations, problem 1.1. And in this investigation, I'm just going to go over an overview of the different types of graphs and how to read them. So the first type of graph is called a dot plot. And in problem 1.1, you're given a dot plot that records the regular peanut butter quality ratings. And so if you look on a previous page in this book, you'll see a list of all these different quality ratings for different peanut butters. And there's different kinds of peanut butter. There's some regular peanut butters and there are natural peanut butters. And so what they did to make this chart is they took the regular peanut butters, these ones here, starting with number 15. So it's a regular peanut butter. And they took these quality ratings, these numbers right here in this column are the quality rating. So if you take these quality ratings, like for Jif it's 76, and for Skippy it's 60, and for Kroger it's 54, and so on down the line. If you just take those numbers and you actually put a dot on the graph for each of those numbers, like there was one that had a quality rating of 11. And so we have our regular peanut butters and their quality ratings. And so each of these numbers corresponds to a quality rating of a regular peanut butter. And the important part of this graph is to understand these here, which are called intervals. So this interval here from 10 to 20, and then another interval from 20 to 30, and then 30 to 40, and then 40 to 50, represent groupings of the quality ratings. Now we could have just graphed each and every one of these on a separate number, but what we want to do is try to create groups. And so we chose an interval of 10 quality ratings at a time. So there's 1 in the 10 to 20 range, there's 4 in the 20 to 30 range, 1, 2, 3, 4, 5, 6 in each of the 30 to 40 and 40 to 50 range, and so on throughout the groupings. And so those intervals show us groupings of the different quality ratings. And obviously these two here, the 30 to 40 and 40 to 50, have the most, which is kind of what we want to do with statistics. We want to kind of see where the most, or what's most common, and what happens most often. If we look at just the 40 to 50 interval, we'll see that the lowest is a 40 and the highest is a 49. And one of the things we need to understand about intervals is that an interval starts where the number in it begins, like this interval starts with the 60 and then goes to everything below 70. So once we get to the 70, the 70s would go in the 70s. So in the 40 to 50 interval, we have 40 to 49 really. In the 50s, we have 50 to 59, or anything less than 60, and so on. So as you look at an interval, the number at the beginning of the interval is included, and then when you get to the end of the interval, you start the next set of numbers. And so if we look at this set, the typical regular peanut butters are all in this 30 to 50 quality rating area. That's where most of them lie. If we were to throw in a 59 or some other number, the 59 would go in the 50s, a 60 would go in the 60s, a 70 would go in the 70s, and so on. If we had a 90, it would be up here in the 90s. And so that's called a line plot, which basically is like taking a number line and plotting your data on that type of plot. Now, another type of plot, or another way we can look at that line plot, is like a bar graph. So we just take those dots and we actually put bars or blocks or rectangles around them. And so really this is the same as our line plot, but now it's more like we consider a bar graph, where we've turned each of these intervals again, into bars. Those are called intervals. And so it looks really identical to what we just looked at in the upper graph, except now we're calling them bars instead of dots or lines on a dot plot. Now, if we are looking at these, we see again that the most common regular peanut butters are all in this 30 to 50 range. So again, not a whole lot of difference. A third way to look at this, which again is really just another way of looking at the same data, is called a histogram. Now, a histogram shows the distribution, but we no longer have the numbers in the bars. So you notice that the change in the histogram is that where we had numbers in these to show the actual quality ratings, now we no longer have those numbers in there. So as we look at this, it's still bars, but we call it a histogram. Our frequencies are listed on the side, so now we have this thing called a count. And so instead of actually seeing the numbers in there, we look at this bar in the histogram, and there were 6 quality ratings in this bar. And there were 6 in this one, and there were 4 in this one. So now we have those quality ratings. We have 4 in this one, 6 in this one, 6 here, 2. We use the count here on the side to see that. 1 of each of these, 2 of those, and 1 there. So now we're just kind of listing things in terms of groups and how many are in each group, not necessarily knowing the exact number in there. And our vertical scale here is really giving us a frequency. So frequency axis, that's what this is called here. This is our frequency axis. So it tells us how many are in each bar. And again, along the bottom, we still have our intervals, 20 to 30, 30 to 40, 40 to 50, and so on. So these intervals now are listed. And there's 6 in this interval, 6 in this interval, 4. And so again, it looks a lot like what we started with the line plot. But we have a different name for it called a histogram because we're no longer listing the actual quality ratings in the bars of what they are. If we wanted to add things to these intervals, we would add them to the appropriate intervals. The scale on the vertical axis is necessary so that we know how many quality ratings are in each of the bars. And so that's how we use those. And we can use these again to describe regular peanut butter quality ratings. Once again, noting that most of the regular peanut butters fall right in to this 30 to 40 range, and we'd probably say right around 40 is middle or typical for regular peanut butter quality ratings. And so that's how you read these graphs. There are different ways of looking at the data, again taking all the numbers off of the original data set for regular peanut butters where they're just all kind of disorganized and not necessarily organized by quality or even able to figure out anything. And so now we're trying to make a model, a mathematical model graph called a histogram or a line plot or bar graph of these data. And so that's how we do that for investigation 1.1.